Small.
Hold on. Can you hear me better?
Still small, but
How about now? Okay.
same. Still small.
Hello, 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 hello.
Yeah. Uh, it. Ya, dokter.
Masuk. Suara masuk, Pak.
Ya, dokter. Ya, dokter. Any problem, dokter? Ya, audio, dokter.
Okay. Good afternoon, ladies and gentlemen. Honorable guests, respected lecturers, colleges, and students. First and foremost, let us give our praise and gratitude to God Almighty, for it's by His blessing and grace that we are able to gather here today in good health to take part in this meaningful academic event, public lecture. Allow me to introduce myself. My name is Aulia Rosa Farha, and it is great honor for me to serve as your Master of Ceremony for today's program. On behalf of the organizing committee, I would like to warmly welcome all of you. We are truly delighted to have your presence this afternoon. Today, we are greatly honored to welcome our honorable speakers, Professor Dr. Muhammad Amiruddin Abdurrahman from University Putra Malaysia, who will deliver a lecture on the evolution of IoT from connected devices to intelligent ecosystem. This public lecture will explore the journey of the Internet of Things from its early stage of simple connectivity to its present role as an intelligent and integrated ecosystem that impacts various fields. Before we begin, let us sing our national anthem, Indonesia Raya. Now, to officially open today's public lecture, it is my pleasure to invite Mr. Jatmiko Endro Suseno, representing the head of Physics Department Diponegoro University, Professor Dr. Heri Sutanto, to deliver the welcoming remarks. Mr. Jatmiko, the screen is yours.
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh. Thank you to Prof. Madya Dr. Muhammad Amiruddin Abdul Rahman as speaker this general lecture. Thank you to all participants in the general lecture. Thank you for attending. Let me introduce myself. My name is Dr. Jamiko. I am the Secretary of the Physics Department, Diponegoro University, Indonesia. I am representing Professor Harry, the head of the Physics Department, who was unable to attend due to having a meeting at the place. I hope this lecture can be an initiation for more collaboration between UNDIP and UPM, research, student mobility, and more. Finally, thank you for speaker Dr. Muhammad Amiruddin. Also, thank you all participants with this lecture can be done successfully. On behalf of the Physics Department, I open the general lecture with the say of Basmalah. Bismillahirrahmanirrahim. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Waalaikumsalam
wabarakatuh.
warahmatullahi wabarakatuh. Thank you very much, Mr. Jatmiko, for your valuable and inspiring words. Ladies and gentlemen, before we continue to the next agenda, we would like to have a group photo session. Kindly turn on your camera and give us your best smile. The photo will be captured by our operator. Please stay on screen for a few moments. Thank you. Okay, 1, 2, 3. Okay, 1, 2, 3. Okay, thank you, ladies and gentlemen. So, move to the next agenda. Ladies and gentlemen, we will now proceed to the main session of today's public lecture. To guide us throughout the session, we are also pleased to introduce our moderator, Mr. Dani Nur Indra Shamputra, who will later accompany and lead the discussion with our speaker. Okay, our moderator today is Mr. Dani Nur Indra Shamputra, a lecturer at Department of Physics, Faculty of Science and Mathematics, University Diponegoro. He earned his master degrees in physics from Universitas Gadjah Mada, specializing in theoretical physics, particularly in gravity models, and his bachelor's degree in physics from Universitas Negeri Yogyakarta. His research interests include theoretical physics, control and instrumentation, as well as applied physics in medical and energy fields. Mr. Dani has published several scientific papers in both national and international journals, covering topics such as FR gravity, solar power system, radiation shielding, and BNCT treatment methods. With that, I'm pleased to hand over the session to our moderator, Mr. Dani, to guide us further. Mr. Dani, the stage is yours. Hello, Mr. Dani.
Hello, can you hear me?
Yes, I can hear you. How are you today,
Okay.
Mr. Dani?
Yeah, I'm fine, thank you. It's great to have to be the moderator for today's session.
Okay. So, Mr. Dani, I'm pleased to hand over the session to Mr. Dani to guide us further. Mr. Dani, the stage is yours.
Okay, thank you, Miss Aulia Rosa, for the time. So, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, yeah, ladies and gentlemen. The Honorable Associate Professor Dr. Muhammad Amiruddin Abdurrahman from University Putra Malaysia. The head of the Department of Physics, Professor Dr. Heri Sutanto, or today is represented by Dr. Jadmiko Endro Suseno, and respected lecturers, colleagues, and dear students. It is my great pleasure to welcome you all today in today's general lecture. So as we can already know today, we gather to learn more about one of the most fascinating and rapidly evolving fields in science and technology, the Internet of Things or IoT. With the theme of today talks is the evolution of IoT from connected device to intelligent ecosystem. We will explore how IoT has developed from simple networks of connected devices into a complex and intelligent ecosystem that transform the way we live, work, and interact. To bring this closer to our context, let me share a simple case. Many of our students is actually designs IoT projects by connecting a single or two sensors, for example, a temperature or humidity sensor to a MCU or to a microcontroller unit such as Arduino or ESP32, and then transmitting the data to an online platform like Blink, ThinkSpeak, or MQTT dashboard. While I think this is a great starting point, especially for our student, but it still raises important questions. How do we move beyond this basic setup and upgrade our IoT system into a more sophisticated, intelligent ecosystem that can integrate multiple devices, perform a real-time analysis, and provide a meaningful decision making? So, this is exactly the kind of question that today's lecture will help us to address. And to help us understand this transformation, we are fortunate to have with us an expert in the field. He has dedicated his career to researching IoT, smart system, intelligent technologies, and has contributed significantly to both academia and industry. But before we begin, I would like to extend a very warm welcome to our distinguished speaker, Associate Professor Dr. Muhammad Amiruddin Abdurrahman from University Putra Malaysia. Hello, Prof. Amiruddin.
Yeah, can you hear me?
Yes, I can hear you very clear. Yeah.
Thank you.
Good afternoon. Yeah. Nice to meet you. I think this is the first time we met each other.
Yes,
Yes.
it is the first time.
Yeah.
Thanks, Danny.
Okay. Yeah. Yeah. Okay. Yeah. It's nice to meet you. So, Prof. Amiruddin, thank you very much for being with us today and for your willingness to share all your expertise with our academic community. We are truly honored to have you here. So, before I give the stage to Prof. Amiruddin, let me introduce our distinguished speaker first. Uh, yeah. Okay. So, our speaker for today is Prof. Muhammad Amiruddin Abdurrahman from Department of Physics, Faculty of Science, and University Putra Malaysia. And he graduated from the Purdue University in the US for his bachelor degree in electrical engineering, and then continued his education in University Putra Malaysia, especially to get his Master of Science degree about sensors and instrumentation. And then he got his doctoral at the University of Sheffield, UK, and University Putra Malaysia. Oh, this is a joint
Yeah, it's joint
degree.
degree. Yes.
Yeah, joint degree. Especially, he is a Doctor Philosophy uh, in wireless communication. And then, currently, he is an associate professor in the Department of Physics, University Putra Malaysia, UPM Serdang, Malaysia. And also, he is the deputy director of the research data planning and management in the at the Research Management Center, University Putra Malaysia. And he has a very high H index. From Google Scholar, he has 19 H index, and from the Scopus, he has 18. Yeah, that's I think that's a really high achievement for academia, where he published up to 60 articles in Scopus Index Journal, and outside that, I believe that it is a very there are much more articles that he has been published, and then he also has the a great funding from the from various sources. The total amount of funding is, as I calculate, it's about maybe around 900,000 Malaysian ringgit, if I'm not mistaken. It is almost like 3 or 4 trillion Indonesian rupiah. So it is a very huge amount of funding he got to do his research. So, yeah, ladies and gentlemen, with such an impressive track records in research and innovation, it is clear that Associate Professor Muhammad Amiruddin has dedicated his expertise to advancing the Internet of Things and intelligent system in ways that truly benefit the society. We are indeed fortunate to have him today. Yeah. But before we begin, allow me to remind you that after the lecture itself will be about 60 minutes, yeah, plus or minus. And then we will have a Q&A session. For the audience, you may write your question in the chat box at any time during presentation, and I will select several of them to be addressed, or you will have the chance to raise your hand and ask directly after the talk. So, without further delay, let us warmly welcome Associate Professor Dr. Muhammad Amiruddin Abdurrahman to deliver his lecture. I would also like to mention that Prof. Amiruddin, you are most welcome to deliver your presentation in English or Bahasa Malaysia, whichever you feel most comfortable with, since I think Malaysian and Indonesian language are very close to each other. So I'm confident that our audience will be able to follow smoothly. So yeah, Prof. Amiruddin, the floor is yours.
Okay, thank you very much, Danny. Can you hear me clearly?
Yes, I can very sorry, I can hear you very clearly.
Okay, thank you very much. Okay. All right. First of all, I would like to apologize because I need to keep it short today rather than it's 1 hour long lecture since I have an emergency due to the death of my uncle. So I need to catch a flight at 5 p.m. today. So I need to make it very quick. Okay, sorry for that. And also
Sorry
thanks
to
for
disturb.
your patience to hear what I'm going to share with you today. Can you see my slides?
Yes, yes.
All right. Okay, so today I'm going to actually give some review of what we have in the IoT field in the previous, and then also what currently that we have, and then we're going to look into what are the future uh, capabilities of AI that we tend to work on this field. So basically, it will be a good platform for us to know if we have some knowledge about IoT and then the interconnected systems, and then what kind of other knowledge that we need to have also in order for us to move forward, especially in the research, because we are at the university, so we must support the research for the industry, basically in your country, in Indonesia, and also in Malaysia as well. So right now we are looking into much more impact that can be done from the university to the industry. Okay, so myself is, you can call me Dr. Amir, all right? I'm from University Putra, Malaysia. So for the first first few slides, I'm going to introduce about the UPM. Okay, so we have quite diverse area of land in UPM. We have about 300 hectares, where mainly because UPM is from the main of pertanian, which is the agriculture university. So we have a lot of lands utilized for agriculture. So we have about 7,000 staff, which 100 1800 is the academic staff, and we have also student mobility programs. If any students from the Diponegoro University also would like to join the mobility programs, you are always welcome. And you are always welcome to my lab as well if you want to interact with me and my other students as well. Okay, so we have 84 responsibility centers, which consists of the faculty centers and institutes. Okay, so we are currently ranked at the 134 in the QS World University ranking. And basically, as Danny mentioned before, that I'm the deputy of the Research Management Center. I also need to do some strategic planning for the university, how we can increase the ranking of the university. So we are looking more into actually building more startups and also doing more impactful research, especially to publish in more impactful journal, especially to Q1 and Q2 journals, so that we can increase our ranking. And at the same time, we are looking into endowment. Also, from the university, from the private sectors, and also from the other philanthropies as well. Okay, so we have about 15 faculties in the UPM, which I am from the Faculty of Science, okay, one of the biggest faculty compared to Faculty of Engineering. Okay, and then we have 11 research institutes, and we have Higher Education Center of Excellence, which is funded by the Ministry of Higher Education of Malaysia. And we have 2 schools, which is one is the postgraduate school, the graduate studies, and School of Business and Economics. Okay, we have around 9 collaborative programs with 6 international institutions where we have collaboration right now. So basically, if Diponegoro University would like to have this kind of program, so we can establish an MOU and also probably MOA after that. All right, maybe this can be talked with the rector or the vice chancellor of the university. Okay, so we have so many international MOU and MOA, especially in terms of teaching and research. And we have about 400 domestic and international collaborations, which consists of collaborations from Indonesian as well. Okay, and then mainly our collaborations spans across Asia, where we have 180 collaborations with the institution in Asia. Okay, so I'm going to start with the concept of IoT. All right. So as we know that IoT term is coined by Kevin Ashton in 1999. So he said that in the future, the computers will know everything, and there is to know about things. So which is actually happening today. Okay, as we can see, so we have the AI integrated IoT devices, where even when we talk to the device, then it can actually operate for us. All right, so we can see this kind of automation is really happening. So they really know, they are really intelligent. Okay, but in the next future, so we might think of the issue with the scalability and also in the interoperability, which I also will talk about that in the next few slides. Okay, so this Kevin actually is actually the British computer scientist. All right, so he termed this concept in 1999, and it's actually based on the RFID tagging. All right, so in the industry, so we have so many products to be produced at a time. All right, so we know that this product needs to be identified. So in order to give the ID, so he gave the idea of RFID, radio frequency ID. Okay, so from there, so this device can be distinguished. But during that time, there are still only the capability is still limited. So it is like we are able to only read, okay, the information from the device, but we cannot even what we call that talk to the device, or we cannot communicate with the device. Okay, so that's the first generation of IoT that we have in 2005. All right, and then now we have the smartphones that utilize a lot of sensors. Okay, a lot of sensors in the phone. So these sensors is actually the things, right? So we have the term of Internet of Things. All right. So these are the things that we need to interact. So in the smartphone, we have a lot of sensors such as gyro, such as GPS, right? Wi-Fi. Okay, we have a lot of pressure sensor, all right, light sensor as well. Okay, so we have those kind of sensors in our smartphone. All right, so in order for us to build an app for the smartphone, so we need to read the data, read the data from these sensors, and then we need to fully utilize this data in order to make things to be intelligent. Okay, so during the initial phase of the smartphone being established, so this IoT device inside the smartphone is only can work in silos. So it cannot integrate with each other. So it cannot communicate with each other. All right. And then now we have the era of AI. So where we have the ChatGPT, Gemini, and so on. All right. So we have this, and then this AI actually, the specialty of AI is the ability to not just read the data, but also to understand the pattern with the data. So that's the capability of AI in order for us to move forward to make the IoT ecosystem is smart and intelligent. So this is what we have right now in 2025. So as you can see from my slides there, so basically we have a lot of sensors in a box. So this kind of things without internet is useless. Okay, because the data would remain there. It cannot be transferred to be utilized or to be manipulated. Okay, but if this data can be manipulated, right? So it would give so much advantages to us. All right. So as you can see right now, surrounding you, of course, you have many sensors, many IoT devices. Surrounding you. Maybe you have the smart TV, all right? So you have the uh, smart, maybe refrigerator. Also, you can say that it's a smart car right now, okay? Because you can actually remotely start your car, right? So basically, it's also based on the connection, all right? So that connection is what we call as the internet, although it's not really internet. So it's actually networks of things, but it is better for us to understand, all right, by using the term of Internet of Things. So it's actually a network of the sensor nodes. Okay, so as you can see here, so this is IoT roadmap. So I have pretty much discussed about the origin of IoT. Okay, so that's what we have in the past. All right, and then we have growth and expansion. All right, and then now what we have is right now is the intelligent IoT era. So where we have the capability, but it's still limited. So we have edge IoT and digital twins. All right, so it's in the edge IoT. All right, it is actually the IoT device that be smart, all right, in silo, okay, rather than it is need to be uploaded to the cloud. Okay, so these are the the issues and challenges, especially when we have different communication protocol that needs to be addressed. Okay, but in the future outlook, there is still much more room to be improved, to be researched, of course. So we will have the capability to work on it. All right. So do not worry. Although the field is going so fast, especially in terms of artificial intelligence, but it won't actually replace the job of especially the physicists and also the engineers. Okay, in a short time. Okay. So this is what we're going to see in the future. Okay, so basically I coined the IoT roadmap in the short term, all right, between 5 years. So what we have, so in terms of short term, of course, we have, as I said before, we have the edge device, and of course, we look into the interoperability standard. And midterm, of course, we look into the 6G and self-healing device, okay? And then the AI and data analytics as well. So what we have right now, of course, we want to look into the fully automated system, okay? And then we have the connectivity. Of course, we must have the much faster wireless connection, especially right now we have the Wi-Fi 7, Wi-Fi 8 is coming soon. All right, and then maybe we look into Wi-Fi 10 and 11 very soon. Okay, and also especially in terms of policy, we don't have so much policy about this, especially whenever it comes with the ethical standard and also in terms of security. So we might need to look into that as well. Okay, so this is what happens in the past. So we have the RFID and also the sensor networks. So as I already mentioned about this, okay, so it has been used for the supply chain management, and it used for the data collection. As you can see before, okay, you want to take the temperature data, the rain data, all right? So that's what has been done in the past, okay? So if you're still working on it, so you are actually has been left behind. So what we have right now, so this device is now be transferred to edge IoT device. So where it has a computing power to make a pattern. So to tell you, all right, so when it is going to rain next, either it's going to be heavy or it's going to be a light rain, for example. Okay, so that's the current IoT device capability. But this needs to, okay, be connected with other IoT device as well, okay, in order to make a what we call a more scalable integration of IoT, especially for smart cities implementation. Okay, so if we can predict the rain, of course, we can also predict the flood as well. Okay, so that's the most important issue. So if we can predict the flood earlier, of course, we can have the evacuation plan earlier. Of course, we can save lives and we can save our valuables. Okay, and then we can also plan for the better future for our cities. Okay, and so that's what we're gonna have next. All right, so but basically we still have the roots. So basically this is what we have in the past. Okay, so this is the first generation application. I think you already know about this, so I will make it faster. All right. So what we have in the past, so you know that we have no intelligence, no AI, no interoperability, and data is still silos. So this is the normal thing. Okay. So I believe you already know about this, the smart homes, the early wearables, and so on. Okay, so the issue right now, how do we scale this IoT? Of course, we will have about 29 billion of devices by 2030. All right. So as you can see on the slide that we have the global IoT market forecast. So there will be more intelligent sensors coming on in next years. All right. So more sensors, more cheaper device will be developed, especially to integrate in so many things. Okay. So what you can see right now is we have many sensors has been integrated in the car. All right. So basically we have EVs that actually it's semi-autonomous. It can drive by themselves, but still driver assisted. But actually, especially if you look into the China, they already have their self-driving taxi. So where it's like Gojek or Grab, okay, that we can book for the taxi, it's actually drive is self-driving for us. All right. So there is no driver. Okay, so that's basically what that is happening in China. But we no longer have that. Okay. All right. But we need to look into what we have. All right. And then we also need to think about the where we want to put this data. All right. So because it need to learn, it need to calculate. All right. So we need to have the cloud computational power. All right. So where we have the AWS, Azure. All right. So these are the cloud provider that we need to depend on. Of course, we cannot rely on our computer anymore because we need to have a quick implementation. We have a powerful computing power where we can afford to buy by ourselves if we want to uh, be at the top of this field. We need to subscribe to this service because it is much cheaper rather than we acquire this data ourselves. Because in the implementation wise, okay, we need to think about the scalability and the impact of the utilization of the data from our IoT. Okay, so these are the issues that we need to tackle. All right, so we need to integrate into the cloud computing platform. And we also have the smartphone. So smartphone, we still rely on the smartphone because smartphone is actually the device that we use personally to communicate. So what we have, as you can see that on the slide, that we have applications, all right? So there's so many apps that needs the deployment. So of course, the knowledge of the computer scientists are still needed in order to integrate, okay, the capability of the sensors, but not just one sensor, but it should be multiple sensors to make a smart app or a super app that we call that. All right. So it will serve as the IoT hub. Okay. So let's say we want to make automation. Okay. So let's say we want to turn on this lamp at this time, and then what? And we also want to turn on the another lamp at another time. Okay. And then, so we need to have this kind of multiple connectivity between these devices in order for us to integrate them together, okay, to make it blend well, so that actually, okay, it can give us energy report. Okay, maybe it could sense us as well. Maybe we are utilizing so much of the the energy resource at this area. Okay, so you might think of how to reduce the energy consumption. Okay, so that is the next kind of capability that we need to think of. Okay, so that we have the comparison. So what I talk about is only about the consumer IoT. So what we have surrounding us, but in the industry, so they need so much of automation. So that's why they need the IoT devices to be connected together. So the difference is that, so it must be made according to industry standard. All right. So we cannot use the normal, let's say the temperature sensor that we have right now for the consumer. So we need to have more what we call it, the more better device that maybe can stay temperature up to 1,000 degrees Celsius, for example. So it must be designed according to the industry standard. So it must have a very stable value or very stable sensitivity. So that kind of sensor needs to be at the industry. Okay. So in order to make their product consistent and also for more productivity, okay, for the industry, okay, especially in terms of improving their operational efficiency and also in terms of safety as well, okay. And then at the same time, so you're having one sensor that can last for 5 years compared to the consumer IoT sensors that can only last 1 year. Of course, it will contribute the cost saving to the industry. Okay, I'm going to look into the smart agriculture. Okay, so we are also working in my group, also working in this smart agriculture as well. So previously we know that we have the soil sensors, we also utilize the drones. So the drones is current technology. So where we we do the seeding, okay, when we utilize that to actually to detect the plants growth and so on. So we can use the drones so to reduce the labor cost. Okay. And the next is we're going to do the predictive analytics. So let's say, when is the suitable time for harvest? Okay. So is it overdue or not overdue? All right. So maybe we have diseases attack, okay, to our plants. Okay. So we need to know so what is happening. So this what we call this as agri IoT. Okay, so it must have couple of sensors to be connected, and then of course we need to have the cloud capability. Of course, as before, we need to make the cost reduce, so we need to subscribe to the cloud provider, and also we need to think of in terms of connection. Of course, the connections cannot use Wi-Fi. Of course, we need to use mobile data, for example, or the satellite data connection, especially for the remote area of agriculture. Okay, so this actually need to be employed on the portal so that we can see what is actually happening on the field. All right, I'm going to show you a video that is based on what we do with our drone in tracking the pineapple and ripeness classification. So I run the video now. I hope you can see that. All right. So we are able to track, okay, where is the location of the pineapple. All right. And then using the AI algorithm. So basically, it will also tag which pineapple is ripe, okay, or is unripe. Okay. So basically, that's our main research problem that we are trying to solve now. Okay, because basically the farmers doesn't know, okay, in terms of maturity of the pineapple. So they just know basically during the harvesting time, so you will collect all of the pineapples, or you will harvest all of the pineapples, okay, rather than choosing the correct pineapple, okay, to know about the ripeness, where it actually can have a better pineapple growth, okay, and also getting more profits, okay, because basically what farmer sells is just they just put into the cart of the lorry, but they actually doesn't know, okay, what actually the value of the pineapple they should sell, okay, to the wholesalers, for example, right? So that's actually the one of practical thing that need to be looked into. Okay, so we are in the era of edge AI and smart IoT. So we have the real-time local processing. So as I said before, and we have this kind of sensor, all right, where we have the predictive maintenance to be done. So it need to be intelligent. So we need to have the AI algorithms to be installed in the device, all right? So it can make their own computation so that it will actually react by themselves if there is something, or it will give us notification and so on. So that we call that as the autonomous. So basically, the fully autonomous, we have not seen it yet. Okay, we might see it in the near future. All right. So there's much more ongoing research that is being done in this field. Okay, in the digital twin, so if you don't know about the concept of the digital twin, so it's like you are replicating. Let's say, you look into the picture that is a oil and gas facility. So in the oil and gas facility, they have so much sensors inside that. So we can redraw the layout or the infrastructure of the facilities, and then there should be a tag value of the sensors, okay, the sensors reading on the screen as well. Okay, so this is very useful, especially for the safety and also for the production as well, because we know the value of the value on the sensors reading would give us indication of how much oil has been extracted. Okay, is it the steaming has been done properly. Okay, so by having the digital twin, we can have a real-time notification sent to us without going to the field directly. So we know basically exactly where the problem happens, and the engineer can take the action quickly without having not known the exact point to be tackled on for the problem. Okay, so that's the digital twin concept. Okay, in the healthcare IoT, so this is one of project in my startup company as well. So we designed a wellness app. Okay, so we have the wearables where we utilize the smartwatch before that, but now we are looking into the smart ring. Okay, and it has been used during the COVID as well. So we need to do contact tracing previously. So because it is pandemic, so we don't know. Every people in the rush. But during that time, we still not ready. Okay, in the Singapore, they make like the contact tracing by using the Bluetooth connection from the smartphone. Okay, but for big countries like Indonesia, all right, even in Malaysia as well, it cannot be done like that. Okay, so we are not ready. Okay, but we are really hopeful that this kind of things where the IoT being connected to billion of device should be realized in maybe the next 2 or 3 years. Okay, and then we are looking into the smart hospital as well. So where of course, whenever we want to have the medicine, of course we don't want to wait at the hospital. We don't want to go to pharmacies. Of course, like we want to have the 24/7 7-Eleven, for example. We want to have the machine over there, okay, that can dispense our medicine. Okay, so we can think of like that for the utilization of IoT. Okay, I'm going to show you one project that we have done for the wellness app. Okay, from the my startup company. So we have this kind of ring. So what I'm wearing right now. Okay, so we have this data that can learn our pattern. So we have the AI capability that can also read the pattern and give recommendation to us. Okay, what to be done? Maybe we are lacking of exercise. Okay, maybe we eat too much food. Okay, maybe the food that we eat is not suitable, something like that. Okay, so that's the invention we were trying to make. Okay, so that's what currently happening, and we still have some issues. As I said, in terms of security and privacy, we still have the hackers going on. Okay, so of course, actually the government portal, we don't want it to be hacked, okay, by these hackers, okay, because it has a lot of data from the people of the country. Okay, so a lot of sensitive data that cannot be less secure. Okay, so we need to make it secure in order for the people to trust for the government to use the technology. Okay, in terms of surveillance as well. So sometimes we know that we were looking for something in our phone, but suddenly we got an advertisement relating to what we are looking for. So basically, we have been surveilled. All right. So basically, that's the smartphone. From the smartphone can hear what we say, and then we want to find for that. Okay. Even not that. Okay. Even if we put the search, even we put the term in the search engine. For example, we are looking for a watch, and then suddenly when you open our Facebook, for example, or Instagram, suddenly there is an ad about the smartwatch. Okay, so we has actually been surveilled. Okay, we are actually cannot hide our sensitive data anymore. Okay, in current world, so we need to think of that how we can keep it safe. Okay, and also we have weak authentication. Okay, especially if our password, so we cannot use just numbers and alphabets only right now. So we need to have different keys. All right, as well. And then also, maybe in the future, it's not safe anymore. We need to have the multiple authentication. We need to verify maybe on the multiple device. Okay, so that needs to be done as well. Maybe we need to have like the face verification. So that's the thing. Okay, another thing is about the interoperability and sustainability. All right, so right now we have challenge in terms of so many connections, so communications standards, all right? So there we rely on. So when these devices are designed or developed according to this standard, we need to think of how we can establish the communication between different standards, okay? And also in terms of impact to the environment. So whenever we have the e-waste, there's so a lot of e-waste right now. Whenever we develop and then the unused or the broken device, so that becomes an e-waste. We need to think of how we can recycle this. All right. So that whenever the unutilized device could be reused for the next devices to be made. All right. So that's the issue in terms of the sustainability. Okay, so next, the last part of my lecture today is we need to look into the next generation IoT. So as you can see that we want to have the traceability. We want to know the source. Of course, this is where the blockchain comes on. Whenever we scan for the QR, for example, on the product, we want to know this product comes from where? Okay, comes from which village? Okay, and who are the suppliers, okay, who are the wholesalers, all right, and then how long have this product has been produced, okay, we want to know that, okay. So that's the capability of blockchain. And then next term is we have the 6G networks, and the upcoming we have the 7G networks has been researched, and we want to have more speed to the our wireless connectivity. And the last part is the self-healing networks is actually, as I said, when we learn the pattern, all right, so we want to know that, so this device, when it's broken, we cannot just leave it like that. So when we have billions of devices, even engineers doesn't have enough hand to fix this device. It need to be self-heal. Okay, so that's the next research can be done in order for this device to have the self-capability to reheal themselves whenever there is an error. Okay. Okay, the next thing is about the human-centric IoT. Okay, of course, we want to have more privacy. We want to have more personalized thing. Okay, they need to learn our pattern. Okay, let's say what we are doing day by day. All right, where we going to work. Okay, where we going to do our exercise. When we are eating, what kind of food that we eat. Where do we eat? All right, so we need to have the personalized IoT. So that need to have like a human-centric IoT. So it's more ethical because it's only belong to us and it's adaptive intelligence. As you look into LLM features right now, so some companies have built like personalized LLM. So the LLM should not receive data from to be transferred to the cloud. Okay, so we can keep our data safe to our own LLM. All right. So that is ongoing research right now as well. And at the same time, of course, we want to improve our quality of life. All right. So that's it for my lecture. So I open to any questions. So maybe I pass back to Danny. Thank you very much for your attention today. I'm happy to take any questions.
Okay, yeah. Thank you, Dr. Amiruddin, for the presentation for today's lecture. Such an insightful and inspiring lecture. But before that, we would like to express our deepest condolence to Dr. Amiruddin and his family for the recent passing of his beloved uncle. May he be granted peace and may the family be given strength during this difficult time. And I believe many of us here, both students and lecturers, are now reflecting on how these ideas connect our work and studies. And of course, some of you may have question in mind. So, as I mentioned earlier, we will move to the Q&A session. I will read selected question from the chat box or the Q&A uh, box. Please feel free to raise your hand, and I will invite you to ask directly. So, Dr. Amir, we have the first question for today from anonymous participant. He said that very interesting presentation for me. Could I ask so far, how are IoT application implemented in Malaysia?
Sorry, I have to turn off my video. All right. But basically, in the IoT, so we have so many IoT system being integrated at the small companies, but we haven't been done in the large scale. So we are still actively working on the IoT implementation, especially for making it as a smart system with the intelligent system with the capability of AI. So that's we are currently focusing on. We are actually planning on the AI standards because this kind of device need to learn about the pattern, okay, the capability of knowing, okay, the data that has been uh collected by this IoT to be used as a meaningful, okay, kind of meaningful uh, knowledge, okay, for us to utilize, okay. So we are actually still lagging behind compared to the countries like US or China. Especially China is the leading country right now. So they have been utilized so many IoT devices. But in Malaysia, we are having this small kind of implementation of IoT at small industries. Yeah, I hope that actually answer the question.
Yeah, thank you, Dr. Amir, for the answer. And I personally think that Indonesia and Malaysia is not so far separated in terms of the implementation of IoT, and maybe I believe that Indonesia is far beyond, sorry, left by the Malaysian because yeah, we are still stuck. We only recently have the Wi-Fi 6, yeah, today, yeah. And yeah, from your lecture, I heard that in Malaysia there are so many places that already have Wi-Fi 7, yeah, for example, yeah. Okay. Any other questions from the audience?
Can I ask?
Oh yeah, please,
Jenny?
Pak Jatmiko.
Okay. Uh, uh, Good afternoon, Dr. Amir. Yeah. The feature, I think IoT, yeah, is like a robot. Yeah. It can replace human work, and it can reduce the number of employees in industry. Yeah. Is it true, Dr. Amir?
Okay,
It's true. Many people can be
yeah, you
unemployed.
can think of like when we have these IoT devices be connected together, of course, we need to design a robot, okay, to make it sense so many things, all right? So, but the robot is a different field, so we need to think of the control system. So where, for example, we need to move the arms and so on. So this IoT is actually a part of the robot integration. So as you can see, as ourselves, okay, our body as a robot, but we need to put on IoT sensors on our body, all right? But for the designing of the robot, okay, we need to think of how to control the arm, okay, how to uh, how to move, all right? And then let's say in terms of how to detect different height. So we need to have the altitude sensors as well, for example, like that, okay? So it's actually part of the integration to the robot. So it's not actually the robot itself, but it's part of the integration of the robot. I hope you can imagine that. Can you imagine that?
Okay, okay. Yeah, I did imagine. Okay, thank you, bro.
Okay, welcome.
Yeah, okay, thank you for the discussions. Any other questions from the audience, please? Oh, yeah, we have a questions from Farhan. Oh, yeah, there is from a chat box from Farhan Hafiz. Let me read the questions. During technology development for health monitoring, pretty interesting based on current risk-based health monitoring device that already so advanced. So his question is, how do you design the analog front end for those sensor? like temperature, oximeter, IMU as well, perhaps, because circuitry that's small and compact will have such a high noise risk, but need to maintain its signal integrity. So
Okay.
he has a question. Yeah. Okay.
Yeah, thank you very much. Okay, right now, so we actually, as I said, we need to work on actually much more advanced field. So that's actually the previous field that has been industrialized. So there has been products on that. So they have pretty much very low noise of sensors and so on. So that's the capability that we have right now. We can actually even buy very cheap sensors from China. Okay? They are much more advanced. So I believe that is if we are working on that field, uh, it will not be much valuable for the research community because that has that kind of product can actually be produced at the manufacturer or at the industry utilizing because how they know about low noise and so on. Of course they have done so much research, especially to avoid the interference and so on. They must have done some shielding to the sensors and so on and then check the signals and data, so they has a much more advanced device. Okay, but for researchers at the university, we need to think of how just to utilize that device, especially to build a powerful algorithm, for example. So that's need to be done because this is the issues that has not been resolved at the industry because there are so many applications. So this industry will focus on the specific algorithms for their products. Okay, so in ourselves, of course, we are looking into the impactful publications and also maybe our research is going to the industry. Okay, so what I'm doing right now, especially focusing on more on the algorithm implementations into the specific applications. And we are trying to build the prototype. Of course, we cannot rely on, of course, there's still some issues, some limitations according to the noise and so on. But that can actually be solved when it been upscaled by the industry. So I hope that answers the question.
Okay. Yeah. Thank you, Dr. Amiruddin. So the key answers may be the collaboration between academia and the industry. Is that right, Dr. Amiruddin?
Yeah,
To
basically,
yeah, to achieve.
yeah, we need to know because when we're looking into the problem by ourselves, we actually don't know. Actually, the other people has actually more advanced than us. So that's why we need to collaborate with the industry because industry has a lot of problems to be sorted on. So we need to solve their problems. So that's our role as the university researcher.
Yes. Yeah. Yeah. I do agree with that statement. Okay. So any other questions? Anyone from the chat box or the Q&A? Not yet. Or maybe I will let me ask questions. There is something interesting for me to I want to know about more. So when we are designing or doing some research in the sensitive field, for example, in the healthcare or in the transportation, especially, and especially for the healthcare, yeah, it is very what is it? The challenges are very different when we are taking the research in other fields. So, in your experience, Dr. Amiruddin, what are the additional challenges when we are doing some research in those what is it? In those sensitive sectors, and how do you what is it, solve the problems or the challenges?
Okay, my approach is simple. So we cannot look, of course, whenever we look problems into a big scale, of course, we think of, okay, so many problems need to be solved at one time. But the approach is we try to tackle one problem at a time. Okay, so right now we see that what the issue that we have, let's say, with the rain sensors on the sensor on the car, for example, for the turning on the wiper. Okay, maybe it's the issue due to the what we call that as uh, the pressure sensor on the windscreen. Okay, maybe we can use uh, image sensor for example. So that can work as well. So when we see the rain coming in, so of course the wiper can turn on. So we might think of different approach, but what we're trying to do is, of course, we're trying to solve it one by one. Okay. And the next thing is, as mentioned by Dr. Jamiko, so it's a robot. The robot is the next thing, the next challenge that we need to think of. Of course, we rely so much on human. Even though we have sensors, we need to still have people to look into the data, people to look into the notification that been sent. Okay, we need to have a robot that can help us to automate this thing. Okay, so that's the challenge that we can think of. So that's the thing that we can also do research in the next future, especially integration of robot with the IoT sensors. Okay.
Okay, yeah, thank you, Dr. Amir. Any other questions from the audiences? Yeah. Oh yeah, we still have the questions from Mr. Adam Sumboko. Yeah. Uh, he is interested in your project about the device that reads the heart rate and blood oxygen levels in the form of a ring. And he asked what type of sensor is used to measure those values. He once tried something similar, but still in prototype, but the readings could not be accurate or one of them at the same time. Both not accurate or one of them at the same time. Okay.
Okay. So basically, of course, when we're doing prototype, of course, so many things, they still have the limitation as we know that. Um, so basically, uh, when we trying to solve the issue, of course, we just have the prototype and then we should have the interest from the industry to take on our product or our project. Okay, so then it can be a valuable product to be commercialized. Okay, so whenever we designing uh, a product, okay, then we need to look into the we just apply up to the prototype. Okay, and then it's up to the collaboration with us with the industry in order to fix the problem. So that's my advice on that. Sorry, I need to change the device because I need to move to the airport right now. Okay. Can you give me a minute to change the device?
Okay, yeah, yeah, it's no problem, Dr. Amir.
Okay. Can you hear me now?
Yes, Dr. Amir, it's very clear. Okay, Sorry, Dr. Amir.
I can, yeah, I can take any other questions.
Oh, okay. Maybe this is the last and the final question from for today's sessions. So from Miss Aulia Rosa actually, and maybe and also most of our students are physics students, so maybe you can answer this question and give the motivation for our students in the physics department. So actually, Miss Aulia Rosa asked about in your lecture, you talk about IoT and its application, IoT and its application. For the from me as physics student, what physics knowledge can support IoT and its application? Hello?
Um, I'm sorry. Could you repeat the question?
Oh, what what physics knowledge can support IoT and its application?
Okay, I got it. Okay, so according to the physics knowledge, okay, according to the physics knowledge, so it's basically you know about the especially about the algorithms. So you need to be uh, at the capability to have the much knowledge into the fundamentals of especially mathematics of the physics. Okay, especially when you learn about the electromagnetism. So you need to really understand how the phenomena is actually happening. And also you need to understand the relationship from the data that that you that you gain, all right, uh, from the sensor to make it useful. So you need to know about the relationship of this data with the phenomena in the physics, especially in terms of uh, light wave propagation, for example, and maybe in terms of optics as well. So you need to have so much knowledge in this so that you can actually predict, okay, whether actually the data that has been given by the sensors that you deploy, is it make sense or not making sense? Okay, so you need to look into the big picture of the physics phenomena and then try to relate what is actually what is actually happening to the project problems that you have. Okay, so basically that's a simple advice. Okay, but the thing is, if you want to make adding more value to the knowledge that you have, okay, you can look into the integration of the knowledge that you learn in different physics courses. For example, you might learn about the algorithms. You might learn about the mechanics, okay, in the physics, and you learn also about the optics. So if you can integrate the knowledge of optics together with the mechanics, and also in terms of the uh, EM, for example, electromagnetism, so that would make you such a very valuable and powerful researcher, okay, in this field. Okay, I hope that answered the question.
Yeah. Okay. Yeah. Thank you, Dr. Amir, for the answer. And I hope it also motivates our student to study harder to understand the concept of physics and to apply those concepts in various fields. So I think that's all for today Q&A session. Thank you for all for the engaging questions and insightful discussions. Unfortunately, due to our limited time, we have to bring the Q&A sessions to an end. Uh, Once again, I said thank you very much, Dr. Amiruddin, for the lectures. Ladies and gentlemen, we have now reached the conclusion of our lecture. The lecture he highlighted the evolution of IoT from cloud-based scaling challenges and smartphone integration through consumer, industrial, and agricultural application to the emerging Edge plus AI era, where we have the digital twins and innovation like smart rings and AI wellness apps. As a physics students, we can integrate our knowledge about the foundation about mechanics, physics, and electromagnetism, and etc., to develop the, for example, the algorithm in the IoT research and application. So, on behalf of the uh, audience, maybe I would like to once again express our deepest gratitude to Associate Professor Dr. Muhammad Amiruddin Abdurrahman for sharing his expertise with us today. We would like to say our condolences to Dr. Amiruddin as well, and we hope that you have the safe flight to your destination. And I would also like to thank all participants for your active engagement and thoughtful questions. Hopefully, today's session will inspire new ideas, collaboration, and innovation in the field of IoT, especially from our physics department. With that, conclude my role as moderator. Now I hand the floor back to our Master of Ceremony, Miss Aulia, to continue the program. That's all from me. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mr. Danny, as a moderator, for leading today's session with such professionalism and warmth. And also, thank you very much to our honorable speaker, Dr. Amiruddin, for such an insightful and inspiring presentation. We truly appreciate the knowledge and experience you have shared with us today, which will surely be of great benefit for both students and academics. Next, we would like to present a certificate of appreciation to our speaker, Dr. Amiruddin, of gratitude for sharing his valuable knowledge with us today. We kindly invite the committee to present the certificate. Okay, we also take a photo together with our speaker, Dr. Amiruddin, to mark this memorable occasion. 1, 2, 3. Okay, thank you. So, ladies and gentlemen, we have now come to the conclusion of today's public lecture. On behalf of the organizing committee, I would like to sincerely thank our honorable speaker, Professor Dr. Muhammad Amiruddin Abdurrahman, our moderator, Mr. Dani, Mr. Jatmiko, and all participants for your active involvement. We hope that today's session has broadened our perspective and inspired us to embrace the opportunities and challenges of the Internet of Things in shaping the future of our societies. Thank you very much for your kind attention and participants. Have a wonderful day and see you in our next academic event. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you.
Waalaikumsalam.
Thank
Thank
you
you,
very much.
Dr. Okay,
Thank
thank
you so
you.
much, Dr. Amiruddin.
Yes.
I'm sorry for the
Okay,
rush.
okay.
No problem.
We can
Same
meet
have subscription.
direct in Malaysia or in Indonesia. Okay, thank you.